Today, we will learn about the stream function, one of the most useful ideas in 2D fluid flow. Imagine you draw curves in the flow field that show exactly where each fluid particle is going. These curves are called streamlines. The fluid flows smoothly along them and never crosses from one streamline to another. We define a special function called the stream function, psi. This function labels each streamline with a number. If one streamline has psi equals 3 and another has psi equals 8, then the amount of fluid flowing between them is exactly 5 units per unit depth. Psi makes it very easy to calculate flow rates. From this single function, psi, we can directly get the velocity components. The x component of velocity u is equal to the partial derivative of psi with respect to y. The y component of velocity v is equal to the negative of the partial derivative of psi with respect to x. This looks a little different from the velocity potential. Still, it is deliberately chosen this way so that the mathematics correctly matches the direction of flow and automatically satisfies mass conservation. Imagine psi as a flow meter drawn on the paper. The change in the value of psi directly tells you how much fluid is passing between any two lines. Constant psi lines act like invisible walls that fluid cannot cross. The stream function psi is a smart mathematical tool that gives us the complete picture of how fluid is moving and how much fluid is flowing in different regions. It makes many problems much simpler to solve. The stream function is used to solve many practical two-dimensional incompressible flow problems. Some common examples are uniform flow, flow in a corner, flow over a cylinder, flow around airfoils, source and sink flows, and flow through channels. In engineering, the stream function is extremely useful in many areas. It helps us in aerodynamics for designing better aircraft wings and airfoils. In hydrodynamics, it is used to study flow around ships, submarines, and other marine structures. It plays an important role in designing wind tunnels so that the flow inside is uniform and smooth. It is also used for studying groundwater movement, such as seepage under dams and flow to wells. Additionally, it helps in designing efficient channels, ducts, pipes, and turbomachinery like turbines, compressors, and pumps. Thank you so much for listening to this video. I hope you have understood the concept of velocity potential function. Consider subscribing to my YouTube channel for more such videos. Thank you so much for watching this video on the stream function. Do you have any doubts? Drop them in the comment section below. I will try my best to reply.